So for this video, we're going to look at whether or not this sequence converges to -1/5. So if we look at the terms of our sequence, -1 to the n plus 2 over 5n, right? We're going to alternatively add and subtract the n's. So we get terms like 1/5, 2/5, -15ths, 1/15th, 3/10ths, -3/25ths, etc. And some of them simplify and some of them don't. If we look at the graph of this thing, well, this sure doesn't look like it's settling down. You have half of the terms kind of getting close to 1/5, and the other half getting close to -1/5. Well, that's a 5. Okay. But it doesn't really look like it's settling down to anything in particular. So again, we need the definition of not converging to A, right? So there exists an epsilon greater than 0. Right, before we had to show true for all epsilons, so here we have to show that there exists one that doesn't work. We had to construct an n last time. Now we have to show that if we can't construct one, it has to not work for all of them. Right? And then we're going to construct a positive n based upon our big N such that we have values outside of our epsilon band. Now, looking at just the first terms of the graph, well, what we see is that terms 2, 4, 6, 8, and 10, right, are consistently greater than our value. And if we can think back to the graph that we saw in the previous graph, right, all the even ones look like they're greater than 1/5. Right, which is at least 2/5 away from the thing that we're looking at. So any epsilon less than 2/5 should work, right? We're going to look around our -1/5, right? 2/5, from here to down here, should do the job since all of these even ones are above it. Because I want to be a little more conservative than that. All right, I'm going to go from 0 to -4/5. So my epsilon, I'm going to choose to be 1/5. Okay? Alright, but I've chosen my epsilon based on the idea that the even terms are above 1/2. So I'm going to choose my little n larger than my big N based upon the idea that I want my little n's to be even. If I want my little n's to be even, well, 2 times any integer is an even integer. So that should do the trick. Right? So now we need to show that the things that we're constructing actually work. Alright? Alright? We've constructed an epsilon, we've constructed an n based upon just any arbitrary integer. Now we need to show that it satisfies our condition. Okay? So our plan. Alright? We're going to construct our epsilon. We're going to let our big n's be arbitrary, construct our little n's based upon that, and then go through the algebra carefully to show that we get something that is larger than our epsilon. Okay. Epsilon equals 1/5. That's perfectly fine. I can say that. Now we're going to let n be any arbitrary positive integer. We're going to let our little n be twice that. Right? For such an n, little n is greater than big N. Little n is n plus n, which is certainly larger than n. Okay. And now we go through and we do the algebra. Alright, so this is our a sub n term of the sequence. Replacing that with what we've defined it as with 2n. Okay, so n becomes 2n. -1 to the n becomes -1 to the 2n, right? -1 to the 2n, well, that's going to end up going away. And since then everything at that point is positive, the negative and the negative will cancel out, right? Everything is positive, so let's drop the absolute values. Okay? We do the algebra, we put things together, and now we can break this up, right? 4n over 10n is the same as 2/5. 2 over 10n is the same as 1/5 over n. All right. If we throw away something that is positive, we'll get something that is smaller. All right? But 2/5 is greater than our 1/5, which was our epsilon, which means we're done. Huzzah! Sequence does not converge to -1/5.